Number 5, we want to know, does this oval represent a function? So again, if I drew a vertical line anywhere, it would hit twice in several spots. So this is not a function because it does hit twice. And then we want to talk about the domain and range. So the leftmost point here comes all the way out to -9, and the rightmost point comes all the way here, looks like about -3. So -9 to -3, again in brackets. Always go in order from smallest to largest, and then the range from bottom to top. So the lowest point, this is a y value of 0, comes up as high as a y value of 4. So 0 to 4. So in the overview, we talked about linear equations, and the domain for all linear functions is going to be all real, unless we're restricted to a real world scenario. So we're going to go from -infinity to +infinity, and that's just given. And then we're going to do the domain for this function. So when you have these fractions or rational expressions, you must be mindful that the denominator cannot equal 0. So I take just the bottom and say it cannot be equal to 0, and solve and find out what makes that 0. So you add 1 to both sides, and you get x cannot equal 1. So we can just say our domain is x is not equal to 1, or in interval notation you need to be able to do both. -infinity to 1, and then you would use a parenthesis indicating we don't actually reach that number. Then union 1 to infinity, just like the example that we saw. So I'm going to do it the shorthand way. I'm going to say not, okay, it don't want me to do that. So I have to do it the other way. So parentheses, I went back a page. Parentheses, and then we're going to do -infinity to 1, and then the union, and then 1 to infinity. So we have to do it that way. It would not let me do the not equal to symbol.